In the last page of our seminar, we'll start off with something hopefully it's kind of basic. And it says, hey, if I have two lines that are the same distance from a third line, I know those two lines have to be parallel. That's just what it is. Now, they have to be in the same plane because it wouldn't be true if they weren't coplanar. Now, let's take a look. How do you find the distance between two parallel lines? So we just actually have to add an extra step in here we'll talk about in a second. So I've got y equals negative 3x minus 5, and I've got y equals negative 3x plus 6. And so what I want to do, first off, let's visualize this. Let's graph both of these in decimals. So I'm going to go, press your X or create a new graph. I already did that. So y equals, and we're going to go negative 3x minus 5. And y equals 3x plus 6. Negative 3x plus 6, sorry about that. Negative 3x plus 6. So now we have these two parallel lines. And people just want to draw a line from 5 to negative 5, like right there. Oh, you can't see that, never mind. But you can't do that because that's not perpendicular. So what I want to do is I want to find a perpendicular line that goes through these two and find that distance. Now, since you got two y-intercepts, you got negative 5 and positive 6. I'm going to use one of them because I can use any point on the line, If I want to put a decimal in here, I don't know if it's going to yeah. I could do negative 4.5 and 8.59 if I wanted to. So let's use one of our y-intercepts. Which one do you want to use? I like positive, so I'm going to use the point 0.06. I get that because my y-intercept on one of my lines is 6. I could have just as well used negative 5. Now, the slope of either one of my parallel lines is the same because we know the slopes are the same. I know that's negative 3. So my perpendicular line is going to have a slope of the opposite reciprocal. That'll be 1/3. So I can write my equation in slope-intercept form because now I know the slope and I know the y-intercept. So I'm going to say y equals 1/3 x plus 6. Now let's graph that. That'll be our third line we're going to graph on here. So I'll go down to line 3 and I'll say y, not x, y equals 1 divided by 3. Get out of the denominator. We'll go x plus 6. See how it crosses right here at 0.6? And my second point is not nice. It's negative 3.3 and 4.9. Everything isn't going to be nice numbers all the time. So my second point is negative 3.3 and 4.9 because it's perpendicular, because I wanted the perpendicular distance. So negative 3.3 and 4.9. Now let's find the distance between these 2 points. So I'm going to say 4.9 minus 6, the quantity squared, plus negative 3.3 minus 0, the quantity squared. Oh, that works out kind of nice, doesn't it? Because of the 0. We're going to save ourselves a little bit of room. Not a ton of room, but a little bit of room. So then we're going to say 4.9. When I say room, I meant work. 4.9 minus 6 is negative 1.1 squared. let me move my paper up so you can see it. So we're going to say that's going to be the square root of negative 1.1 squared plus negative 3.3 squared. And I think I'll show my work a little bit more than I usually do. So if I square negative 1.1, I get 1.21. A negative times a negative is a positive. Plus 3.3 squared is 10.89. 89, let me rewrite that. Then if I add those up, I get the square root of 12.1. And then I put a wavy equal sign because I'm pretty sure I'm going to have to run my answer. And 3.47. Maybe 3.5. I like 3.5 better. Let's go 3.5. That's easier to write. And that's our distance. Now notice on these problems, although I'm letting you use Desmos, and you can use Desmos on your test, you still have to show work. Desmos just saves us some time of doing a huge system of equations between these two. So what I want you to do now is do your MT3 LT10 assignment. Take a picture of your work. You're going to have work at least on these distance problems, and then upload it to Google Classroom.